This is the second video on logarithms and logarithmic functions. Now, what I want to do in this video is just a couple of examples. So let's solve the equation y equals log base 4 of 64. Now, the way I solve this is by reading this statement the way I did in the previous video. This statement says that y is the power I raise 4 to in order to get 64. Y is the power I raise 4 to in order to get 64. Now, hopefully you know that 4 cubed equals 64, which means, of course, that 3 is the power I raise 4 to get 64, which means that y equals 3. So 3 is equal to log base 4 of 64. Let's do another one. So let's solve y equals log base 5 of 1 divided by 625, 1/625. Alright, so I've changed this a little bit. We're not looking at just nice integer or natural number values. We're looking at a fraction, but I still think this is possible. In fact, I'd like you to give it a shot. So go ahead and hit pause and work through this question on your own. Get as far as you can, see if you can't get an answer, and then hit play and we'll check your work. Okay, hopefully you've tried this on your own. So what this statement is saying, of course, is that y is the power I raise 5 to in order to get 1/625. Well, let's do a little bit of an exponential investigation to get to this answer. I know, for example, that 5 to the 0 is 1. 5 to the minus 1 is 1/5. 5 to the minus 2 is 1/25. 5 to the minus 3 is 1/125. And 5 to the minus 4 is 1/625. Well, there's our answer, because -4 is the power I raise 5 to in order to get 625. So -4 is equal to log base 5 of 1/625. So hopefully you've noticed something. You've noticed possible outputs include both positive numbers, here's a 3, and negative numbers, here's a -4. So let's look at what the graph of a logarithm looks like to confirm that yes, in fact, the range of logarithm includes both positive and negative numbers. Alright, so in order to graph our logarithm, I'm actually going to start by graphing an exponential function, because we remember that exponential functions and logarithmic functions are inverses, and that's going to help us graph it. So let me graph maybe the canonical exponential function, which is e to the x, the natural exponential function. Well, as we know, every exponential function has a y-intercept of 0, 1. Now the exponential function goes up as x gets larger and down towards 0 as x gets more negative, but it never quite reaches 0. So there's our natural exponential function. Now if I want to graph the log with that same base, log base e of x, we actually have a special notation for that because this number e is so valuable. We write it as ln, and we call this the natural log. So ln of x is the natural log of x. So if I want to graph the natural log of x, the way I do it is, remember, we can draw this dotted 45-degree line, and then we'll reflect the graph of our exponential function right across that 45-degree line. So let's start by reflecting the point 0, 1, reflects to the point 1, 0. And what I'm going to get is something that looks kind of like this, right? Here we can see that the upper portion is reflected over here, and the lower portion is reflected down here. And so we can see that, yes, in fact, the range of the natural log of x, ln of x, it really does include both positive and negative values. And in fact, we can also tell that the domain of natural log of x, we can see what that is. Well, if I wrote this in interval notation, that's 0 up to infinity, and it doesn't include 0. Right? I cannot take the natural log of 0. That is undefined. How do I know? Well, anything that's in the domain of natural log has to be in the range of the inverse. But the range of e to the x, it never gets all the way down to 0. It's 0 to infinity. So this range of e to the x is exactly equal to the domain of the natural log of x. And of course, the domain of e to the x is equal to the range of the natural log of x.